Good morning, students. Today I am going to take your another class. I am Nipun Ahuja, Assistant Professor, MAE. We are doing today class on engineering mechanics. The next theory topic, we are going to discuss collision or impact and types of collision and loss of energy. I will discuss later. Though I have written here, I actually forgot to erase this thing. So today I will discuss collisions and types of collisions. Right. Right. First of all, we will discuss what is collision or impact and what are the types of impact. Basically, a collision of two bodies is actually impact of two bodies for a very small interval of time, and during this time, these two bodies exert very large force on each other, and this process is actually known as impact, right? Uh, for Before we go and understand types of impacts, first of all we understand what is line of impact, right? Now whenever two bodies impact each other, there is a normal of normal this normal uh, uh, there is a normal of collision of or normal to the surfaces of the of the two bodies. That normal is known as line of impact, right? So now let's discuss two types of impact. One is central and non-central impact, another is direct impact or indirect impact. First of all, let us discuss central and non-central impact. As it is written here, when the mass centers C1 and C2 of the colliding bodies lie on the line of the impact, it is called central impact. Otherwise it is called non-central or eccentric impact. What does it mean? It means that this line of impact of the two bodies, when they collide, and if these this line of impact passes through the center of the body, that is C1 and C2, then it is known as central impact. And if it is not passing through the center, like in this case, the center is here, and the line of impact is here, then it is known as non-central impact or eccentric impact. Another way of uh, of of deciding the type of impact is direct impact or indirect impact. Here it is given. Um, just a minute. Here it is given, if the velocities of the two bodies before collision are collinear with the line of impact, it is called direct impact. Otherwise, it is called indirect or oblique impact. You can see in this case uh, this velocity VA and VB, they the direction of these velocities are exactly aligned are exactly aligned with the line of impact. Then is a direct impact. And if the velocity, like in this case VA VB, and in this case VA and VB, the velocities are not aligning with the line of impact, that is known as indirect or oblique impact. Now body can be oblique as well as central also, or eccentric or direct impact also. Like in this case, you can see there's a oblique non-central impact. What does it mean? That this line of impact does not coincide with the C1 and C2, so it is non-central, as well as VA and VB are also not aligning with this line of impact, so it is a oblique also. So this is actually oblique non-central impact case. In this case, this is an oblique central impact. That is, this line of impact coincide with C1 and C2, so it is central impact, but is not aligning with VA and VB, so it is a oblique, so it is a oblique central impact. And in the third case is when um, which is known as direct central impact. In this case, the line of impact not only coincide with C1 and C2 but also aligned with VA and VB. So this is known as direct central impact. In our course, we are only interested in direct central impact. So we will be discussing only this case, that is direct central impact. But you should know other cases also, that is non-central impact, oblique impact. So these things should also be known. But here we are discussing only direct central impact. So let's go ahead. Now, let's discuss direct central impact and coefficient of restitution. As I have discussed that when two bodies having velocity Va and Vb in particular direction, and if the line of impact coincide with the line of impact, the center coincide with the line of impact, as well as velocity also aligned with this line of impact, then it is known as direct central impact. So this thing is here clear. Now there is another topic, that is coefficient of restitution. This topic I also want to discuss here. The coefficient of restitution is basically a negative of velocity of separation and velocity of approach. Now, as in this case, the initial velocity of the two bodies are Va and Vb, and when they, after the impact of their velocity would be Va dash and Vb dash. So definitely when the body gets separated, then the velocity difference would be Vb dash minus Va dash, and when when actually these bodies are approaching each other before collision, then the difference would be Vb minus Va. So basically coefficient of restitution is equal to minus of Vb dash minus Va dash upon Vb minus Va, where Vb dash Va dash are the velocities after impact, and Vb and Va are velocities before impact. So this coefficient of restitution has a very important role to play. Besides coefficient of restitution, there is also conservation of energy, that is uh, the initial momentum, sum of initial momentum and final momentum are equal, as in this case MAVA plus MBVB equal to MAVA dash plus MBVB dash. So MA, MB are the masses of these two bodies, VA, VB are the initial velocities, and VA dash, VB dash are the final velocities. So uh, uh, we in solving the numericals, these two equations are very important. This is conservation of energy and the coefficient of restitution. So do remember these two equations. These are very important equations. Now let's go ahead. Let's do one numerical on coefficient of restitution. In this numerical, there is a ball A of mass 1 kg moving with a velocity of 2 meter per second, impinges directly on a ball B of mass 2 kg at rest. Find the velocities of the two ball after the impact. Assume the coefficient of restitution E equal to 1 by 2. Now, in this case, there is a ball A which has mass 1 kg and velocity 2 meter per second. It impinges another ball which has mass 2 kg and that is at rest. Coefficient of restitution we know equal to 1 by 2. We have to find the velocity of the two balls after the impact, that is Va dash and Vb dash. So these things we know, Ma, Mb, Va, Vb and E 1 by 2. Here we will use the two formula which I discussed in last slide, that is conservation of momentum as well as coefficient of restitution. So conservation of momentum says MAVA plus MBVB equal to MAVA dash plus MBV dash VB dash. So this, when we put this 1 into 2 plus 2 into 0 equal to 1 into VA dash plus 2 into VB dash. So we get this equation VA plus 2 VB dash equal to 2, and another coefficient of restitution, we put this formula, and we put the value of VA and VB here, and we get another equation VB minus VB dash minus VA dash equal to 1. Solving this equation and this equation, we get VA dash equal to 0 and VB dash equal to 1 meter second. So the ball A comes to rest after the impact and the ball B attains the velocity of 1 meter per second. So I hope you have understood the very basic numerical related to coefficient of restitution. Now let's go ahead with our further topics. Now, as I discussed the the collision, so here I am discussing little physics uh, happens during the collision. Actually, when the two bodies, like in this case is Ma and Mb, having velocity Va and Vb, they are having direct central impact, and before collision, this velocity is Va and Vb. Now, when the body actually collides, at that time there is a deformation starts happening in these two bodies, and this deformation happen until maximum deformation occurs, and after the maximum deformation these bodies uh, depart from each other, and they attain Va dash and Vb dash velocity. This state is known as period of restitution, and this state is known as period of deformation. This is explained in this graph also. You can see that before impact, the state is like this, and after this, here at this point, collision actually happened, impact actually happened, and then deformation start happening, and deformation keep on happening, force keep on increasing with increase in time, and at this point the deformation become maximum, right? And once the state reaches to the maximum deformation, then uh, then the body starts departing from each other, and then another period start, that is period of restitution, that is delta t2, and in this time period the force start decreasing, and bodies uh, start regaining its shape. So this is case of period of restitution. Now this period of restitution is zero in case of plastic impact, and in this is actually case of elastic impact, right? So if there would be plastic impact, then this period of restitution would be zero, though there would be period of deformation would be there in the case of plastic uh, plastic impact, right? So this is actually physics behind collision. So we have understood the period of deformation, period of restitution. So this theory is also very important. So do remember this theory. Now let's go ahead. Now we will discuss some important cases of impact or collisions. There are two cases. One is perfectly elastic impact case, another is perfectly plastic impact case, and then we will discuss some cases of perfectly elastic cases also, because perfectly plastic case is not in our syllabus, but we should know the perfectly elastic case as well as perfectly plastic case. So first of all, discuss perfectly elastic impact case. In this case, when there is a perfectly elastic impact, at that time coefficient of restitution is equal to 1, right? So when we put this formula in the coefficient of restitution formula, we get this equation: vb dash minus va dash equal to v minus vb plus va. This is wrongly written, minus vb plus va. So this is one equation we get, and we also know that there is a conservation of momentum also there in case of perfectly elastic impact. So when we put this formula, and when we get this thing here and this thing here, we get MA VA minus VA dash equal to MB VB dash minus VB. So now using this thing, uh, uh, when we put change this thing into this thing, VA plus VA dash equal to VB plus VB dash. So we get actually two equations, this equation and this equation. Now when we multiply this thing to this thing, we get this MA minus VA dash into VA plus VA dash equal to MB VB dash minus VB into VB dash plus VB. So finally we get MA VA square plus MB VB square, MA VA dash square plus MB VB square. We multiply both sides with 1 by 2. So we actually get the kinetic energy of the two bodies before impact is equal to kinetic energy of the two bodies after impact. So we get that when there is a perfectly elastic impact, at that time E equal to 1, this thing. Second, there is a conservation of momentum, this thing. And we also get that there is a conservation of kinetic energy also, the conservation of energy also. So for elastic impact, there is momentum and energy, both are conserved. So do remember, whenever there is a plastic impact, you can use these formula, conservation of momentum as well as conservation of energy, right? And E equal to 1 also, right? So now let's do another case. The another case is perfectly plastic impact, that is when equal to 0. When we put this thing in this formula, we get VB dash equal to VA dash equal to V dash. That is uh, that is when there is a plastic impact, then the final velocity of both the bodies would be equal, that is VB dash VA dash, which is equal to V dash, right? So this is the one thing we get when there is a plastic impact, perfectly plastic impact, right? And another thing is that in this case there is a conservation of momentum there, but there will not be conservation of kinetic energy. So in perfectly plastic impact, there will be conservation of energy, conservation of momentum, but conservation of kinetic energy will not be there. Conservation of energy will not be there. So we can use this formula, and as we got that v dash equal to va dash equal to v dash, So we get MAVA plus MBVB equal to MA plus MB into V dash. So finally we get final velocity which is equal to MAVA plus MBVB upon MA plus MB. So basically if there is a perfectly plastic impact, then we can get the final velocity which is equal for both the bodies, that is MAVA plus MBVB upon MA plus MB. So from these two cases we can get that in perfectly elastic case there is a conservation of energy, conservation of momentum and E equal to 1, and for perfectly plastic case there is E equal to 0, and there is only and the final velocity is same after impact, and the conservation of energy is also there. So this we have understood, right? Now let's do some more cases of elastic impact. These there I will discuss three more cases of elastic impact. First case is impact of two equal masses, right? So let us suppose that there are two bodies having mass ma mb. These two masses are actually equal, ma equal to mb equal to m, and their velocities va and vb both are in same direction. Va is greater than vb. So here we can apply the conservation of momentum, that is ma va plus mb vb equal to ma va dash plus mb vb dash. So we get va plus vb equal to va dash plus vb dash because ma and mb are equal. And another formula which we can use, that E equal to 1, which is equal to minus VB dash minus VA dash upon VB minus VA, which gives VB minus VA equal to minus of VB dash minus VA dash. When we solve this equation and this equation, we get VA dash equal to VB, VB dash equal to VB, which means that the final velocity of mass A will be equal to the initial velocity of mass B, and the final velocity of mass V will be equal to initial velocity of VA. That is, after an elastic impact, the two masses exchanges velocity. So this is a very important case. When there is a elastic impact and the masses of two bodies are equal, then actually after the impact, they exchanges their velocity, that is VA dash equal to VB and VB dash equal to VA. So do remember this formula. This formula will definitely be going to use in further numericals. So these cases are very important cases, right? Now let's discuss another case. The next case is one body immovable and a very large, having very large mass compared to other body. So suppose there is a one body which is immovable, like like in this case there is a floor on which one ball impacts. Now this ball is a very small mass ma, and the mass of the floor is very large, which is almost infinite compared to ma. So we write here mb equal to infinity, and the velocity of this floor is zero because it is immovable, and the velocity of this ball is va, right? So we again use conservation of momentum here, that is MAVA plus MBVB equal to MAVA dash plus MBVB dash. Now, as we know that MB equal to infinity, so what we do, we divide MB from both the sides. We get MA upon MB into VA plus MBB equal to MA upon MB VA dash plus VB dash. So, since MB is infinity, so when we put this thing as well as we put VB equal to 0, we get VB dash equal to 0. That is the final, that is when this ball strike this floor, the initial velocity is 0 of this floor, as well as even after impact the final velocity would also be 0, that is VB dash equal to 0. Another formula we can use, since this is an elastic collision, so we are putting E equal to 1 minus VB dash minus VA dash upon VB minus VA. We get this VB minus VA equal to minus VB dash plus VA dash. Now we already know that VB equal to 0, and we have calculated VB dash equal to 0. So we get VA dash equal to minus VA. That is, the final velocity of this mass will again be equal to VA, that is initial velocity, but it is in opposite direction, that is ball will go in opposite direction, that is upper direction, provided the collision is elastic. So this is another important case, that if the ball strikes the floor, then and if it is and if the floor is immovable as well as an infinite mass, and the velocity then the velocity remains the same even after impact for this mass ma, but in opposite direction. So this is another important case. Third case, a body strikes another body of equal mass at rest. In this case, there is a mass ma and there is mb. These two masses are equal, that is m, which is equal to m, and the final velocity and the initial velocity of this mass is 0, and the velocity of ma equal to va, right? So initial velocity of ma is va, right? So now we again use the conservation of momentum, that is ma va plus mb vb equal to ma va dash plus mb vb dash. We put the formula for vb equal to 0, we get va equal to va dash plus vb dash. This is one equation. Another coefficient of restitution we use equal to 1, which is equal to minus vb dash minus va dash upon vb minus va. We get vb minus va equal to minus vb dash plus va dash, where vb is equal to 0. So when we solve this equation and this equation, we get va dash equal to 0 and vb dash equal to va, which means that after the impact of this mass on this mass, where this mass is stationary and this mass is moving with velocity va, then the final velocity of this mass will become 0, and uh, and this mass will start moving with the velocity va, that is the initial velocity of mass a, that is the striking mass ma stops after the imparting its entire velocity to the mass mb. So these three cases are very important for elastic collision. Definitely in our course we are having elastic collision, but we should also know the case of perfectly plastic case also, right? So these cases are very important, which we will be using in further numericals also, right? So this is what actually I wanted to discuss with you in today's class. In further topics, I will discuss next topic, the loss of kinetic energy during impact. That is, when there is an impact happen, what would be the loss of kinetic energy? There is a formula derivation, and this formula would also be going to use in solving numericals. So this thing I will discuss, as well as we will do some numericals on collision or impact, right? And then I will give you assignment or unit 3. Though I have given unit 3, unit 4 assignment 4 also, but I will give you some more assignment, and I request you all students to complete these this assignment within next 3 days of my sharing assignment, right? So thank you, thanks a lot. I wish that this presentation would have uh, gone good for you, and you have learned certain new things in this presentation. I will do doubt session again, maybe on Microsoft Team or Zoom app. Let's see how I will do doubt session. Maybe I will do this doubt session tomorrow or day after tomorrow. So let's see. I thank you. Thanks a lot.